All right, hello everybody. Welcome back to these amazing math videos. Today we are going to look at some more solving techniques. So we have 3 days of solving. Last class was the first day, and we just went over some basic techniques just to get an idea of what this whole solving piece is, right? We talked about, getting the numbers on one side, getting your trig function on the other side, dividing so that the x was, or the trig function was by itself, and then doing inverse trig function. All right, so that was like basic intro level. So now we're going to start doing a little bit more advanced, and then by next class you'll learn kind of the most advanced solving that we're going to do. All right, so today the techniques that we're going to look at are more algebraic techniques. So we're going to look at factoring, pulling out a greatest common factor, and combining like terms. All right, so here we go. Where's my button? Oh, I lost it. There it is. Okay. All right, so here are some more. These are the techniques we're going to be looking at today. So getting the variable on one side. So we already kind of talked about that a little bit in our last video, right? We want to make sure that the variable is on one side and then our numbers are going to kind of be on the other side. So that's kind of the technique that we talked about last class. So we've kind of already done this one right here. All right. Using trig identities to get one trig function. All right, so sometimes if you have multiple trig functions in a problem, you may want to think about using one of those trig identities. This is actually something that we're going to talk more about next class. And I also don't want the pen to be this thin, so we are going to make it a little bit fatter because it's easier to see. All right. Cool. Hold on. I'm going to do this with all of them because I think I made them all thin to fill out a homework. And I don't want that. There we go. That one's the right size. Okay, cool. We're back at it. All right. So next class we're gonna be using a lot more of our trig identities to kind of manipulate our problems to get to where we want to go. So that's going to be kind of next class. The one we're going to be looking at today is going to be the factoring and using GCF. So this is kind of our technique we're going to be looking at closely in this video. Okay, and I would say that these ones are like medium level solving problems. So, so we're just going to look at some examples. All right, so it says solve the following equation for theta. Now that weird E symbol means in the interval. It's nothing really that you need to worry about. Just know that our interval is between 0 and 2 pi. So this tells us two things. Number one, this tells us that we are in radians. All right, because 2 pi is a radian measure. All right, so our answer should be in radians. This also tells me that I'm going all the way from 0 to 2 pi, so I'm doing one full rotation on the circle, and I'm getting all the solutions that fall within that range. All right, so here we go with our first one. All right, so if you look at it, this is the first time that you will have seen so far multiple trig functions. So I'm going to actually zoom in a little bit because this is actually kind of not very... There we go. Okay, so we have 2 cosine theta sine theta plus 3 cosine equals negative square root of 2 cosine theta plus 3 cosine theta. All right, that's a lot of stuff. All right, so first off, we want to try and combine like terms if we can. All right, so the cosine times sine can only match up with other cosine times sines. All right, and there aren't any. There's only the one cosine times sine piece. So that's kind of already combined. There are no like terms. But I have a 3 cosine theta and a 3 cosine theta. So I'm going to try and subtract that over, which is kind of nice because what's going to happen is it's going to end up canceling. So minus 3 cosine theta minus 3 cosine theta. And that actually makes 0. So that goes away. So now what I'm left with is 2 cosine, oops, I forgot the S in cosine. It happens. 2 cosine theta sine theta equals negative square root of 2 cosine theta. Now this, we want to pause, and I hope everybody watches this because we talked about this in our last video. One of the things you cannot do is divide out by solutions. So what I see happen all the time with a problem like this is students will divide by cosine theta on both sides. And that's going to cancel those out and cancel those out. And then they'll tell me that we're left with 2 sine theta equals negative square root of 2. That is incorrect. That will get you some of your answers, but you just divided out all of the cosine answers. So this is not okay. No, you cannot do this. All right, what you want to do instead. So if you ever feel like you want to divide out by something because then things are going to cancel, I want you to think, move everything to one side and pull out the greatest common factor. All right, so if division seems like the right call, it's not if it's a variable that you're dividing by. What you want to do instead is the only division we're allowed to do because it doesn't lose answers, and that is a greatest common factor, dividing out by a greatest common factor. It doesn't make it go away, but it puts it on the outside of the parentheses so you can deal with it separately, and that's what we want. All right, so how you would really do this problem, all right, so the real way is you would add square root of 2 cosine theta to the left-hand side so that you get it equal to 0. All right, so you would have 2 cosine theta sine theta, and then you're adding the 2 cosine, adding root 2, not just 2. Square root of 2 cosine theta, which is going to give you 0 over there on that right-hand side. Okay, so we move everything over. So if you ever feel the need to want to divide by a variable, which theta is a variable, don't do it. You move everything to one side and you do what we call taking out a greatest common factor. So you notice we have a cosine in both of our terms. So what we're going to do is we're going to divide it out. We're going to pull it out to the front. All right, so we pull out a cosine theta from each piece, and what that's gonna leave us with is a 2 sine theta plus a square root of 2. Remember, when you pull out a greatest common factor, you should be able to distribute and end up with the original thing that you had, right? So if I wanted to check to make sure this works, if I were to distribute this cosine back into my parentheses, it should give me 2 cosine times sine plus square root of 2 cosine, and it does. All right, so remember, we're not doing anything weird, we're just like backwards distributing. Okay, now, when we're at this step, all right, there's a rule called the zero roots property. All right, it tells us that if you have it set up to multiplication and it's equal to 0, that means if this piece equaled 0, 0 times whatever the other parentheses is would be 0, right? 0 times anything is 0. All right, also, if this equaled 0, then that whole side would be 0. All right, so the 0 is the key piece here. Sometimes I see students that they solve they kind of do, you know, solving, but they have like an extra number, and so they just move the extra number over to the other side, say it's 5. And they think that they can just like equal these two parentheses to 5 and it's the same thing as being equal to 0, and that's not true. All right, so the only time where you can, you know, set parentheses equal to something and solve is when you're setting it equal to 0, because 0 times anything is going to make 0. 5 times anything could be anything. It doesn't work that way. All right, so this only works with 0 on that other side of the equal sign. All right, can't work with anything else because it's not true. All right, so like I said, I just saw that when I was grading honors tests. I want to make sure that we understand it has to be 0 on that other side. Otherwise, you can't set the parentheses equal to things and solve. It won't work. All right, so now that we do have 0, we are going to set each piece equal to 0, and we're going to solve for theta. So we have cosine theta equals 0, and we have 2 sine theta plus square root of 2 equaling 0. All right, so we'll start with the cosine theta because it's a little bit easier. All right, so all we need to do is we need to get theta by itself. In order to do that, we need to move the cosine. In order to undo cosine, you take the inverse cosine of both sides. So we have inverse cosine, inverse cosine. All right, so this is now theta's by itself because those two cancel. All right, and then we have inverse cosine of 0. So remember, when you have an inverse, that means what's in the parentheses is the value. You're looking for the angle that has that value. So for this problem, if it's cosine inverse, all right, we're looking for an angle that has a cosine value of 0. Cosine is our x-coordinate, so we go to our unit circle, and we go to that table, right? We have that table in our notes, and you say, okay, when do I have an x value that's 0? Everywhere from 0 to 2 pi. And that's going to happen at 90 degrees or pi over 2 because we're in radians. Remember, we know we're in radians because it says 0 to 2 pi. So pi over 2, this also happens at 3 pi over 2, which is 270 degrees. So at the bottom of the y-axis. So top of the y-axis and the bottom of the y-axis. So those are our solutions for the first piece. All right, but we still have this second piece to do. So this one's a little bit more work. All right, so we have 2 sine theta plus the square root of 2. We're going to subtract root 2 from both sides. Oops, I don't know why I keep missing the square root. Those cancel. So now I'm left with 2 sine theta equals negative square root of 2. We divide both sides by 2. All right. So then I have sine theta equals negative square root of 2 over 2. All right. We want to get theta by itself. So what we're going to do is inverse sine on both sides to get the sine to go to the right hand side of the equation. So inverse sine. All right, those cancel. And then we're left with theta equals inverse sine of negative square root of 2 over 2. All right, so again, we go to our unit circle or the chart, whichever one you like to use, and we want to figure out for what angles do we have a sine value of negative square root of 2 over 2. So remember, sine is our y value. All right, so we're looking on that unit circle and we're trying to figure out when is y going to equal negative square root of 2 over 2. Well, those are going to be your 45-degree angles. All right, so now we just need to figure out which quadrants would have a negative y value, and that's going to be quadrants 3 and 4 because that's when y is negative. All right, so in quadrants 3 and 4, my 45-degree or my pi over 4 angles are going to be 5 pi over 4 and 7 pi over 4. And those are our solutions. All right, so for this first problem, we have 4 solutions. We have pi over 2, 3 pi over 2, we have 5 pi over 4, and we have 7 pi over 4. All of them would work if we went back to the original equation and plugged the values in. All right? So moving on to our next one, once our writing goes ahead and updates, gets all up in there. 5 pi over 4, comma, 7 pi over 4. Oh my gosh, it's so slow. Okay, cool. All right, so 5 pi over 4 and 7 pi over 4. All right, moving on to our second one. All right, so this is going to be similar techniques. All right, so again, we find ourselves with 2, actually, hold on. Okay, I changed the problem because it was too similar to the first one. So, unpause. All right, So this is going to give us, the last one was going to be the same kind of techniques, pulling out a greatest common factor. This one's going to be a different factoring technique, which we definitely also need to go over. So that's why I changed it really quick. So here we have 3 cotangent squared theta equals 2 cotangent theta minus 1 plus 2 cotangent squared theta. So what we want to do is kind of just like normal solving problems, right? We want to kind of get everything over to one side of the equation and combine our like terms. All right, so I'm going to go ahead and subtract 2 cotangent squared thetas from both sides. So 2 cotangent squared thetas. Bam. All right, so that's going to give me 1 cotangent squared theta equals 2 cotangent theta minus 1. All right, and I want to move those things over as well. All right, now that it's caught up, I had to pause because it took forever to catch up on the writing. Okay, so we have cotangent squared equals 2 cotangent minus 1. All right, so we still want to move everything to one side because if you look at this, this kind of has that same like ax squared bxc kind of vibe, which is our quadratic. And so to handle quadratic, we need to move everything to one side of the equation. All right, so we're going to subtract 2 cotangent and we're going to add 1. So subtract 2 cotangent, add 1. Those cancel. All right, and so what we're left with is cotangent squared minus 2 cotangent plus 1 all equals 0. All right, from here we want to go ahead and we want to factor, just like you would factor a normal quadratic equation. All right, now a quick trick that can sometimes make this easier because I know some students look at this and they're like, I have no idea how this is normal factoring. So my recommendation is to use substitution. So instead of having cotangent theta, replace your cotangent theta with x. All right, so that's going to then change this to x squared minus 2x plus 1 equals 0. I don't know why the writing is like messed up. Cool, plus 1 equals 0. This is more doable for most people. Now, this is not necessary, but it can help you factor if you're having a hard time. All right, so now we go, I like the box method. All right, so we put our x squared in the top corner, we put our 1 in the bottom corner. We're looking for two numbers that multiply, so they have to multiply to a times c, and they have to add to b. All right, so a times c is 1 times 1, which is 1, and b is negative 2. So it has to multiply to positive 1, has to add to negative 2. That's going to be negative 1x, negative 1x. So factoring, you get x, a minus 1, and a minus 1. So this ends up factoring to x minus 1 times x minus 1. Now we can take each parentheses, equal it to 0. All right, so that's x minus 1 equals 0, and this is also x minus 1 equals 0. So x equals 1, x equals 1. Now you might be wondering, Miss Lastly, this is supposed to have cotangents in it. Well, now that we have x by itself, we can go ahead and we can replace x with cotangent. All right, so I'm now going to replace x with cotangent. So I now have cotangent theta equals 1, cotangent theta equals 1. All right, so that might make it a little bit easier.